There is a mystery inside Neptune. This glowing blue orb on the outermost frontier of our solar system is not what you would expect. It is not frozen into silence. It is not a passive, unremarkable sphere drifting in the dark. It is a violent, churning electric world driven by forces so extreme and counterintuitive. Even now, decades after our one and only close encounter, scientists are still trying to make sense of what they saw. Neptune defies easy explanation. To understand Neptune, you have to understand just how far away it is. It sits roughly 4.5 billion kilometers from the center of our solar system. Even moving at the speed of light, the absolute speed limit of the universe, it would take over 4 hours to travel from the Sun to Neptune. A commercial airplane would need 500 years to make the journey. Even the fastest spacecraft ever launched takes the better part of a decade. Jupiter is already remarkably distant, but Neptune is not just twice as far, it is 5 times further than the gas giants that already feel remote. It occupies a region so dark that sunlight is 1,000 times weaker than on Earth. On Neptune, midday looks dimmer than a heavily overcast evening. For most of human history, we had no idea it existed. Even with a telescope, it appears as nothing more than a faint, blurry dot in the stellar background. This brilliant blue planet, 4 times the diameter of Earth, remained unknown until 1846. It was not spotted by chance, it was found by mathematics. The story begins with Uranus. Astronomers tracked it carefully, but it did not move quite right. It wobbled, deviating from its predicted elliptical path. It was as if something invisible was tugging at it, pulling it gently off its expected course with a persistent, unseen gravitational hand. 2 mathematicians, Adams and Leverrier, independently concluded that another massive planet must be hiding beyond Uranus, distorting its orbit. In September 1846, astronomers at the Berlin Observatory pointed their telescope at the indicated position and found Neptune that same evening. Neptune belongs to a category called the ice giants. They contain compounds like water, methane, and ammonia in a hot, dense, superheated fluid. Our single moment of contact came in 1989, when NASA's Voyager 2 arrived after 12 years. It remains one of our most successful missions. Using a rare planetary alignment, Voyager used the gravity of each planet as a slingshot. Without it, the journey would have taken decades longer. The spacecraft was equipped with television cameras and magnetometers, a remarkable toolkit for the era and the vast distances involved. What Voyager saw was extraordinary. Neptune blazed a vivid, saturated blue, a shade unlike anything else in the solar system. As Voyager closed in, it became clear this was not a quiet world. This was a place of violence, churning at the edge of the dark. Neptune is the windiest planet in our solar system, not in terms of lightning or geology, but in raw wind velocity, a record no other world can match. Wind speeds here exceed 2,100 kilometers per hour, faster than the speed of sound on Earth. They are 5 times stronger than our most powerful tornadoes. The circulation is deeply strange. At the equator, winds blow against the planet's rotation, while polar winds follow it, creating massive shear forces. In 1989, Voyager 2 photographed the Great Dark Spot, a vast hurricane nearly the size of Earth, sustained by the same energy powering the supersonic winds. Nearby, bright streaks of methane ice, nicknamed scooters, race around the planet even faster than the storm itself at supersonic velocities. But these storms are transient. When Hubble looked years later, the Great Dark Spot had vanished. Neptune's weather evolves on timescales of years, not centuries. Where is this energy coming from? Neptune receives only 1,000th of the solar energy Earth does. The Sun cannot be the engine. Uranus, which is closer to the Sun, is an almost still world. Neptune is further and colder, yet it is the most meteorologically active planet beyond Jupiter. Neptune is warmer than it should be. Something deep inside is generating substantial, sustained internal heat, driving the atmosphere into a frenzy. To find the source, we need to go inside. Below the blue atmosphere lies a vast mantle of water, ammonia, and methane mixed under crushing pressure. At millions of times Earth's pressure, methane molecules are torn apart. The freed carbon atoms begin to crystallize. They become diamonds. Vast quantities of diamonds are continuously formed, sinking downward through the mantle in slow, immense cascades. diamond rain falling through a planet. These jewels eventually reach a zone so dense they float, potentially forming a deep diamond ocean around Neptune's solid Earth-sized core. This falling rain creates friction, and friction generates heat. That heat radiates outward, rising until it collides with the brutal cold of deep space. This thermal contrast is the engine. The weight of falling jewels ultimately powers the supersonic winds and the storms we see from the outside. Uranus is still because its diamond rain is less vigorous. Neptune's intensity is fueled by the falling crystals hidden deep in its invisible interior. It is one of the most remarkable chains of causation in science, a planetary weather system powered by the weight of falling jewels. Neptune's atmosphere was not the only surprise. As Voyager 2 swung away, it turned its cameras toward the moon system and found something truly astonishing: Triton. Enormous and cold, Triton is a world of extraordinary complexity, covered in nitrogen ice with active geysers firing plumes kilometers into its thin atmosphere. But Triton's most important secret is its orbit. It circles Neptune in the wrong direction, retrograde. A moon this large cannot be captured through a simple encounter. The leading theory is a binary exchange capture. Triton was once part of a binary pair, two dwarf planets drifting together like a slowly tumbling dumbbell. When they strayed too close, Neptune's gravity tore them apart. Triton was bound to the planet, while its companion was flung away into the outer depths. Triton's arrival was catastrophic, scattering Neptune's original moons. The surviving moon system today is a record of that violent arrival billions of years ago. The story is not over. Triton is spiraling inward. In billions of years, it will cross the Roche limit, where Neptune's tidal forces will tear the moon apart. From Triton's ruins, something magnificent will be born. A vast, diffuse disk of material that will encircle Neptune in a spectacular ring system. Neptune has sculpted the architecture of the outer solar system. The Kuiper Belt, the vast ring of icy dwarf planets, bears Neptune's gravitational fingerprint. Pluto is Triton's twin, born in the same region but separated by circumstance. While Triton was stolen by Neptune, Pluto drifting into a stable resonance. Voyager gave us a tantalizing glimpse, but Neptune has remained unvisited for over 3 decades. Now, the scientific community is planning a return. The most developed concept is Neptune Odyssey. It would spend years investigating the planet, its rings, and Triton with a full suite of modern instruments. It would deploy an entry probe to provide direct measurements of the deep atmosphere, temperature, pressure, and wind speed measured at first hand. The challenges are immense, a 15-year journey powered by nuclear generators. But if we launch in the late 2030s, we can finally solve these deep mysteries. Neptune remains one of the great frontiers, a world of diamond rain and stolen moons, puzzling us since our brief look in 1989. The blue light it sends across the empty space is a signal, faint, patient, and waiting for us to finally go back and listen.